In this section, I'd like to talk about Marlowe and give you the complete definition of the language. I'll do that by showing you how it's defined in Haskell, and then I'll conclude by showing you how it looks in JavaScript. Okay, in a nutshell, what is Marlowe? It's an embedded domain-specific language. It sits inside Haskell, and it's a Haskell data type. But recently, we've added the facility to be able to author Marlowe in JavaScript, and I'll explain at the end of this how we achieve that. It's described by a semantics in Haskell, if you like, a reference interpreter, which is executable. So we can experiment with the language. So we've got a very clear but executable definition of a language. It runs on a blockchain, Cardano, which is UTXO based, but with an extension to allow some data to pass between transactions. So it's extended UTXO. It runs on the blockchain by running a Plutus program. Plutus is the general purpose language that sits on Cardano. So we run using that. And we're able to do, because it's a special purpose language, it's a DSL, we can do particular things with it. We can analyze programs to check the behavior down every possible execution path. We do that using what's called an SMT solver. And we're also able to prove things about the system or classes of contracts. And finally, we have the Marlow playground in which we can develop and analyze and simulate Marlow programs. But what I'm going to concentrate on here is the definition of the language itself. So here you can see Marlow has 5 constructs. We can close a contract down, we can make a payment, we can do one of 2 contracts according to an observation. We can wait for something to happen. And that's the most complicated construct in Marlow. We'll talk about that in detail in a second. And we can also capture a value if we need to use later on in contract execution. Suppose we wanted to capture the value of an oracle, say. We could capture that and then use it later on. Okay, but let's take a look at what these different contracts do. So what a close contract does, it comes at the end of contract execution. It's the end of a contract. And what we do at that point, closing a contract down, involves us refunding money, any money left in the contract, to the account holders. So each role in the contract, each participant will have an account, and the money is refunded to those role holders. What about a payment? Well, a payment is made from an account, here AC, to a payee, the person receiving the amount, and we have a value transferred in a particular token. So typically that will be ADA, but it doesn't have to be. It can be any token that is valid on the Cardano blockchain. So, and then the final value there is the continuation, what we do next. So we make a payment from AC to the payee of value amount in the token top. And that's what a payment does. What does if do? If has 3 arguments. It's got 2 contracts, cont T, cont F, and we carry on as cont T if the condition is true. Otherwise, we carry on as cont F. So that's the way we can branch. We can do one thing or another depending on this condition. Now, what about the when? The when has 3 components. It has a number of cases, it has a timeout, and it has a continuation. What happens? So let's see what happens there. Each case is itself an action and a contract. And what happens is, before the timeout happens, when one of the actions happens, we do the corresponding contract. It's got various possible actions. When one of them happens, we do the corresponding contract. And that's it. But if we reach the timeout and none of the actions has happened, we do cont. So we know whatever happens, this contract will progress by the timeout. It will do cont. But if any of the actions happens before, then the corresponding contract is executed. So we talked about pay and if and when and close. The only other thing to talk about is let, which, as I said, captures a value. Let me just say a tiny bit about some of the other data involved in this. We have actions, we have observations, and we have values. What are these three types of component? Well, an action can be one of three kinds. It could be a deposit. And what happens there is that a party is asked to deposit a value of a particular token in the account of a payee. So it's paid into the contract, and once it's in the contract, it belongs in the payee account. So I could put money in, but if I put it into your account, and the impact of that is if there's any money left in there when the contract ends, you get the refund, not me. So we say pay it into the contract, but into your account, into the payee's account, rather than the party's account. Of course, the payee and party may be the same. Usually they are, but they're not. This allows them to be different. Here we have a choice. We have a range of values that a choice could take, and we name the choice. It's often 0 or 1 for true and false, but it could represent a value of an oracle. Or we could just notify an observation. An observation compares values just by less than or equal, and combines them with logic. And values are whole numbers, integers, and they include things like the money in the account, the current slot, choices that have been made, and so on. So values are numbers that represent interesting things in the contract. And that really is it. That's pretty much the whole of Marlow. Now, what I've shown you was Haskell, but here in JavaScript is how these things look in JavaScript. And you can see they look pretty similar. We have a defined constant called pay that takes a party, a payee, a token, a value, and a continuation contract and produces a contract. So just like pay had these 5 arguments in Haskell, it's similar in JavaScript, albeit in a slightly different notation. When is similar, and as you can see here, also deposit, which is an action, and value equality, which is an observation. These things correspond very closely to what you've seen in Haskell. So if you're comfortable writing JavaScript, you simply plug together these contracts inside JavaScript in exactly the way you would do it in Haskell. So they're just recapping. I said this was Marlow in a nutshell. Let me say a tiny bit about how it works on the Cardano blockchain. And as I said, it's an extended UTXO. So as a transaction is made, as an output is redeemed and becomes the input of another transaction, data can flow, as it were, across that boundary. And that allows us to make sure that all the transactions we put on the blockchain conform to the contract, or all the transactions related to the contract actually conform to the terms of the contract. We can only put a contract transaction on the blockchain if it conforms to what the contract should do. And we enforce that by what's called the Marlow interpreter, which is a program in Plutus. So that's how Marlow works on-chain. We put transactions onto the blockchain and check that they conform to the contract. But the question is, where do those transactions come from? And the answer is, using the same contract, we're able to generate those transactions inside a user's wallet or the user interface. So the wallet or the user interface will generate transactions that go on the blockchain. Now we need the wallet to be involved because we need to approve transfer of assets, transfer of cryptocurrency into a running contract in a deposit. So we need to use the wallet there to approve that. And also the wallet or user interface will show to somebody who's engaged in a contract what they can do next, any choices they have to make, the state of the contract, and so on. So that provides the user interface for an end user to interact with any contracts that are running. Okay, so I think that has given you a summary of Marlow in a nutshell. You've seen the basic construct in JavaScript as well as in Haskell.